All right, so we are going to go over Study Guide 1, review of Organic Chemistry 1, and you guys all have successfully passed Organic Chemistry 1, so I'm going to go over quickly for Organic 1, Study Guide 1. We learn organic molecules, alkanes, CH4 like CnH2n plus 2. That's the general formula. Alkenes, C double bond C. Those are the hydrocarbon chains. Alkynes, C triple bond C. And alkyl halides, CCl. So those are organic molecules. And we learn structure and nomenclature. We know how to draw full structures, condensed structures, line structures, wedge notations, Newman projection, and chair structures. We know IUPAC rules for naming, constitutional isomers, conformational isomers, stereoisomers, chiral compounds, and resonance structures. Those are the ones we learn and we are going to practice later in these study guides. We learn in general chemistry 1 bond angles, hybridization such as sp, sp2, sp3, bonding orbitals, and formal charges. And then in these organic molecules, we learn properties, mainly melting point, boiling point, solubility, and optical rotations. They are depend on chain length, branching, functional groups, stereoisomers. Those properties depends on these factors. Then reactions. There are a couple of like 3-4 common reactions such as addition reaction, substitution reaction, elimination, and rearrangement reaction. There are acid-base reactions and oxidative cleavage. In oxidative cleavage, you need O3 and KMnO4. In addition reactions, basically you add in carbon double bond carbon alkenes and carbon triple bond carbon, where you can break those bonds and add an electrophilic addition of HX, electrophilic addition of X2, addition of water such as oxymercuration, hydroboration. So those are typical addition reactions. Elimination, dehydrohalogenation of alkyl halide and vanillic halide. Substitution reaction, SN1 and SN2. SN1 typically tertiary alkyl halide and SN2 in primary halides. Grignard radical substitutions, Gilman substitutions, those are typical ones. Rearrangements, basically carbocation rearrangement during electrophilic addition of alkenes and tautomerization of anol. So those are typical reactions that you might have learned. In mechanisms, there are E1, E2, SN1, SN2, acid and base, and electrophilic additions. Those are polar. And radical reaction substitution in alkane and alkene, how it converts to alkyl halide. So those are typical mechanisms. So let's start practice few things in here. We need to draw the full structure, and we know CH3, CHCl, CH2, CH3. And when you draw this structure, this is a full structure, and when we find out chiral carbon, so you can see this is a chiral carbon which is bonded with 4 different groups. And we can draw its R and S stereoisomers. You can see wedge and dash on this carbon and this carbon. This is R and S. This is its skeletal structure, and the name is 2-chlorobutane. The most stable Newman projection, you can see 1 CH3 down here, 1 CH3 up here, and that's the stable one. It has the this is 2-chlorobutane, this is 2-chloro-2-methylpropane, and this is 2-chlorohexane. Those are its structures, and when you look at it, it has more branches and less it has more kind of chain and less branch. So C has higher boiling point than B and then A. So that's where you can see how those structures and properties affects. This is CONH2 amide group. This is its structure. This is amide group. This is hybridization. This is C is sp3 hybridization. This is C2, it's sp2 hybridization. Oxygen is sp2 hybridization, and this is sp3 hybridization. This is the bond angle CCO 120, CNH 109.28. And so you can see all based on this structure, you can identify the hybridization bond angle and the types of the bonds. And you can draw the orbital picture, overlapping orbitals, and then you can see that how this electron flows from nitrogen to this bond and then goes to oxygen and forms the partial positive on nitrogen and partial negative to oxygen. Okay. So now when you look at degree of saturation, again for C3860, its degree of saturation is 1. Again, I would highly suggest to recall the formula how to calculate degree of saturation. But typically C3860, you can multiply 2 times 3 plus 2 minus 6 divided by 2, which will give you 1. There are 3 constitutional isomers, alcohol, ketone, and cyclic ether. And for C3860, and we need to find out which one has a higher boiling point and why. We call cyclic ether has a higher dipole moment, and that leads to greater alignment ordering in liquid phase. And alcohol, they form hydrogen bond with water molecules. So now here it is. These structures, which one is more stable? This is not stable, they are on the same side, but this is on the opposite. So B is stable, and out of this one, this is the best energy diagram. And then trans and cis structure of the stereoisomer, when you draw that, this is a trans and this is a cis structure. Okay. Let's see here. 1-butene, cis, 2-butene, and trans. So this is a cis structure, C double bond C. This is cis structure. This is a trans structure, and this is 1-butene. These are stereoisomers. And when you rank those in stability, trans is more stabilized, you can see, then cis, and then 1-butene. When you write its equation, hydrogenation of 1-butene in platinum catalyst, you can see you are adding hydrogen. So basically, you are breaking them and adding hydrogen in here. Now, when you look at the stability diagram, 1-butene and trans 2-butene and cis 2-butene. And then look at the energy diagram, 1-butene, trans 2-butene, and cis 2-butene. And those are the transitions. So cation is basically decrease the activation energy, and it is basically increase the reaction rate. So that's the function of the catalyst, and that's why we are using palladium, not platinum. I'm sorry if I say platinum. No, it's palladium. Yes. Okay. These are basically, you need to memorize addition of HX on C double bond C and how this X is added here and it breaks the double bond. Same thing with alkene, it breaks the triple bond, one bond, and Cl is added. Addition of X2, and you can see how this double bond breaks and add X here, X here. It's an addition reaction. Halohydrine formation. So you can see how OH is going to add here and X is going to add here and double bond breaks. Water addition, oxomercuration. This is hydroburation, BH3 and THF and H2O2 and OH. So you can see how these things you need to memorize basically. Hydrogenations, H2 and catalyst, oxidative cleavage, O3 and KMnO4 you needed, and zinc or H3O plus, you can see how they are oxidative cleavage and C double bond O and C double bond O forms. So those are typical one. and later we are going to practice, but I would highly suggest to memorize those, make a flashcard and memorize so you can apply later in this practice, in this study guides. And you guys have learned that in Organic Chemistry 1. But if it is a long time, then I would highly suggest to write those reactions and write in a flashcards, try to memorize it. And main thing, you need to find out when there is a double bond or triple bond, how that breaks. This is acid-base reaction. So this one, this hydrogen is going to shift and going to join with the NH3, and there is a radical. This forms alkylations, and in the same case you can see those are typical ones. All right, these are alkyl halides synthesis of alkyl halides. So you can see this alkene, HX and ether, C double bond, and then it's finally it forms the C bond X. So start with addition reactions, then polar mechanisms, and then Markovnikov additions and trans product across the triple bond. So that's the sequence you need to find. This is alkane is given, and X2 and HV. So when you have this X2 and HV, it's a substitution reactions, and then radical mechanisms, and then multi-substituted product forms here, okay, and mono-substituted products possible. Now this alkene and NBS and HVCCl4, in that way you can see substitution reactions, radical mechanisms, and that's where you need to think through and follow the sequence, and you start with this two, and what you get, what product is possible, that you need to go through step by step. Grignard reactions, so Rx, and in presence of Mg and ether, you can see RMgX, and in H2O, RH forms. Gilman reactions, 2Rx, Li and pentane, CuI and ether, and you can see R bond R dash forms. SN1, tertiary carbon, SN2, primary carbon, and how those nucleophile attach. This produces acidic mixture. This produces inverted product. Elimination 1 and elimination 2. So you can see those typical reactions mechanisms, and you can apply. Now once you made those flashcards and memorize that, you apply here. This is a reactant and this is given, this is addition reaction. As soon as you see that, identify addition reaction and then start working on it, you can see this is the carbon and Cl is added to here. This is also an addition reaction. Br is here and Br is here on this carbon. So that way you can predict and identify. Okay, hydroborations reactions, H2 and P decatalysis, it's the double bond breaks and forms the addition. So those things you need to identify. The entire catalyst, elimination product, elimination, where you can see you need to identify which one is going to eliminate. So based on the previous reactions and memorize, you can see what are given here and apply. Hydroborations, or this is HBr and ether, what's going to be happen and predict. This is oxidative cleavage, KMnO4, O3 and O3. So those are oxidative cleavage happens. This is oxidative cleavage. This is substitution reactions. So some of those things you need to memorize, typical reactions, and apply. These are mechanisms. Now electrophilic addition reactions. So this is the reactant, HCl, H is positive and Cl is negative. And you need to see this double bond is going to pull by this hydrogen positive, this pi electron, and form CH bond, and there is a partial positive here that is going to attach by chlorine here. So that elimination reactions, you need to suggest those mechanisms. This is tertiary carbon, X and KOH, and how this OH is going to add this at this C, and X is so it's kind of substitution, or yeah, elimination reaction. This is SN1 reaction. As soon as you see tertiary and nucleophile, tertiary carbon, this is primary carbon and nucleophile, it's SN2 reactions. This is elimination reactions. Yes, OH is needed, strong OH, so which can eliminate. All right, acid-base reactions. This act as a base, and you can see how they react. This is acid-base reactions. If it is more complicated, you look at the starting point and then find out the product and then start working on those steps. So if it is complicated, NBSHBCCl4, starting point, write its product and then start with step-by-step process. Again, this is kind of E2 elimination reaction is already been given, so you don't have to identify starting point, KOH, and then you can see, well, what are the site is active, and that's where you can start organizing information. So another way to practice reactions, make your own study guides, including examples of electrophilic addition of alkene of HX, X2, HOX, and water oxymeration. It's Markovnikov's. Electrophilic addition to alkene of HX and water by oxymeration, mercuration, I'm sorry. And then other additions, hydroborations, cationic addition of H2, Lindar catalyst, and then addition of H2 with Li and NH3. Dehydrohalogenation, E1 and E2, substitution, SN2, SN1, SN1, radical substitution. So those things you need to make your own standard reactions, and then you can apply. So here we have, and then again, end of the chapter problems. You need to suggested work on end of the chapter problems. That will help you to review organic 1. So this is the end of study guide 1.